Good afternoon, my YouTube viewers. In this particular video, what we're going to do is we're going to carry out some clinical trials using the Mann Whitney U test. And we're going to do that by writing a program in Python. And so in order to execute the program in Python, what we need to do is we need to import some libraries. So the first library that we're going to import is NumPy as NP, which is a numeric library, and it also creates NumPy arrays. The second library that we're going to import is Pandas as PD, which is a data processing library and also creates data frames and series. The third library that we're going to import is matplotlib.pyplot as PLT, and that is a visualization library. And the fourth library is from scipy.stats, we're going to import Mann Whitney U. So scipy is a scientific library in Python, and stats is a statistical module within scipy, and Mann Whitney U is a function within the statistical module. So now what we have to do is we have to generate some simulated data. And in order to generate the simulated data, we're going to set our seed. And you set your seed so every time you run the program, it will initialize to the same values. So you do that by typing np.random.seed brackets 42, or you can put any number you want inside the brackets. And now what we're going to use is we're going to use the gamma distribution to create synthetic data, and this gamma distribution is a skewed distribution. So it has a shape of 2 and a scale of 2. So group 1 equals np.random.gamma brackets 2, 2, 50. And 50 is your sample size. And group 2 is np.random.gamma brackets 3, 2, 50. So now what we're going to do is we're going to perform the Mann Whitney U test. So stats, p-value equals Mann Whitney U brackets group 1, group 2, alternative equals two-sided. And now what we're going to do is we're going to print the test results. So we're going to print the test statistic and the p-value. So we come down here to the bottom of the program, and the test statistic is 741 and the p-value is 0. And since the p-value is 0, that indicates that the null hypothesis will not be accepted, and that means that there is a significance difference between the two samples of data. And we will be making a box plot, but you can see there is a significant difference between group 1 and group 2. And that's why you get a p-value of 0. So there is a significant difference between group 1 and group 2. So now what we're going to do is we're going to combine the data to create a data frame. So data equals pd.dataframe brackets, curly brackets, group group 1 times len group 1 plus group 2 times len group 2. And outcome, np concatenate group 1 and group 2. So now we're going to make a box plot to visualize the data. plt.figure brackets fig size equals 6, 4 brackets data.boxplot brackets by equals group, column equals outcome, grid equals false, patch artist equals true, box props equals dict, face color equals light blue. The title is patient outcomes comparison, skewed distribution. You're not going to have a subtitle. X label is group, Y label is outcome, and your grid is axis equals Y, comma, line style equals dash, comma, alpha equals 7. So now we're going to add annotation for the p-value, plt.text, brackets, 1.5, comma, data equals square brackets, outcome dot max minus 2, comma, p-value, comma, color equals red, comma, HA equals center. And now we're going to show the plot. It has a plt.type layout, and we're going to show it. And then we've already shown the box plot, so now we're going to create a histogram. So plt.figure brackets fig size equals 6, 4, plt.hist brackets group 1, comma, bins equals 15, comma, alpha equals 50, comma, label equals group 1, comma, color equals blue. And then plt.hist brackets group 2, comma, bins equals 15, comma, alpha equals 7, comma, label equals 2, comma, color equals orange. And then the title is histogram of patient outcomes. X label is outcome, Y label is frequency. We get a legend. Your grid is X equals Y, comma, line style equals dash, comma, alpha equals 0.7. And then we show the histogram, and you can see you've got group 1 histogram and group 2 histogram, and both of the groups are skewed to the right. But you can see that the scale of group 1 is smaller than the scale of group 2. So that concludes this video. The next video, we're going to do some more non-parametric tests, and I hope you decide to watch it.